Good day, everyone. You are welcome to Master Lucas Academy. So, this is the problem we have to solve here for today. Here we have what's called chemical kinetic, CHM407. From the past question of National Open University, we are given that during the chemical kinetic study of the reaction, 2 moles of A react with 1 mole of B to produce 1 mole of C and D. So, the experiment were run in the following way, number 1 to number 4, and the concentration of A, every data is given here. And the question here now says, determine the order of the reaction. So let us fall on question number 1 that says we should determine the order of reaction. In order to determine the order of this reaction, we must know the order of A, the order of B as well. So we are going to start with the order of A. The order of A, we are going to calculate it in this way. When the concentration of B is held constant at 0.1, 0.1, then the order of A is going for this one here and this one here, with respect to the formation of D that we have in this place. So from what we have there, we are going to take this one as inertia, we take this one as final. That will be the final of A over inertia of A equals to, from what you have in this place, this is the final of D. So the final of D over the inertia of D. Okay, there we go. So what are we going to have there next? From this place, the final is given to be 0.4 divided by the inertia, which is 0.1, then equals to, in this place, the final here is given to be 2.4 times 10 raised to power minus 2 divided by the inertia, which is 6.0 times 10 raised to power minus 3. Okay, so when you do the arithmetic of this one, what are you going to have there? 0.4 divided by 0. This will give us 4. With respect to that, that is 4 raised to power 1. Now, in this place, when you do the conversion of this one is as the same as saying 0.024, exactly, followed by 0.006. That is what we're going to have. The 0.024 divided by 0.06. And that will also give us 4. So this one is also equals to 4. It's 4 raised to power 1. So we're going to have 4 raised to power 1 equals to 4 raised to power 1. So order of A equals to 1 in this place. Okay, so for B, the order of B, now what are we going to do there? Check it out in this place. Here, we are given this one to be 0.3, 0.3. So when this one is kept constant, what happens to the value of this one here? You check it out. So we are using this and we are using this in this place. So what are we going to have there? We are going to have, that will be, let this be your final, let this be your inertia. That will be final of B over inertia of B equals to, so it will be going for this, it will be going for this. So we're going to have final of D over inertia of B. Okay, now from what we have in this place, so the final is given to be 0.4 over 0.2, then close the bracket, equals to, and then we are going to have 2.88 times 10 raised to power minus 1 divided by we are going to have 7.2 times 10 raised to power minus 2. Okay, so from what we have here, 0.4 divided by 0.2 is expected to give you 2. Now, since we have this value in this place, then what are we going to do? That means order of B equals to 2. So everything together will give you what? That is order of A plus order of B. That will be 1 plus 2 will give you, that is total order. Total order will give you 1 plus 2, which is equal to 3, which is per molecular. Okay, so that is what we have there. Now, with respect to what we have in this place, the question says determine the order of the reaction. So this is the order of the reaction. As you can see now, it is molecular in nature. Let us proceed to the next question that says calculate the value of the rate constant. The value of the rate constant, which is the Kn, that is what the question says you should look for next. So in order to look for the value of this, as given in the question, calculate the value of the rate constant, what are we going to do? We are going to use the value given here to solve the problem. So now, using the value that we have in this place, as you can see, so this is what we are going to have there. Our rate equals to this. That is 0.024. Then here we go next. With respect to the individual values given there, when A equals to 1, take note, B equals to 2. Then we say that our rate equals to Kn into bracket A raised to power 1, followed by, we're going to have B raised to power 2. Okay. So rate is 0.024 equals to Kn, then into bracket, our A from that question is 0.4 raised to power 1, followed by our B is 0.1 into bracket, followed by raised to power 2. 0.024 equals to Kn. Here, this will still give you 0.4 times. This one should give you 0.01. So 0.024 equals to what are you going to have when you multiply this together? 0.00 followed by 4. Okay, Kn. Divide both sides by 0.004, 0.004. Now Kn equals to, when you divide 0.024 divided by 0.004, you should have 6 as the value. So after obtaining 6 here, the last question says, write the rate law for the reaction. So Roman figure 3, rate law, the rate law will be, there we're going to have R equals to, our Kn is now 6 into bracket A raised to power 1 into bracket B raised to power 2. That is the final answer to the question there. Take note of that. The final answer. In this place you have this as well. So in this one that you are reading here, you can have R equals to Kn into bracket A raised to power 1 followed by B raised to power 2. Such as exactly what I've written in this place. So that is what the question asks you to do.